Okay, next one. Next, draw the graph. Current will shoot, and this voltage is called breakdown voltage. Next one, for an ideal diode, reverse resistance is how much, Dharani? Reverse resistance is how much for an ideal diode? Reverse resistance infinite. For an ideal diode, the reverse resistance is infinite. Highest value is infinite. Highest value. For a non-ideal diode, reverse resistance in the range of kilo ohm. For a non-ideal diode, reverse resistance in the range of kilo ohm. Kilo ohm. Okay. Next, write down the next study. Breakdown in diodes. Breakdown in diode. This is pure theory. There are not much things. Breakdown in diode. Okay, we'll write a note, then along with that we'll study. Breakdown. There are two types of breakdown in diode. There are two types of breakdown. What are the two types? Sorry, correct. Two types of breakdown diode. One is avalanche breakdown. Number one, avalanche breakdown. Breakdown in diodes. Avalanche breakdown. Second one, Zener breakdown. Zener breakdown. Okay, so first one is the avalanche breakdown. First point, avalanche breakdown. How these avalanche breakdowns are happening? I told in case of a reverse bias, reverse saturation current is there. That is because of what? Because of minority carriers. Correct? Because of the minority carriers. So what will happen means, listen very carefully into the board. So we have a reverse bias. So P type and N type. P is connected with negative and N is connected with positive. I am only marking minority carriers will be here. So here minority carriers are electrons, here minority carriers are holes. Whenever you increasing the reverse voltage, what will happens to this minority carriers? Minority carriers speed of movement is very fast. Okay, there is a minority carrier in P type is repelled with a battery, and this is hole. This side positive and hole charge positive, and positive holes will move like this. So whenever if you are increasing this voltage, what will happen? The movement or the speed of movement of minority carriers increases. This minority carriers in the speed increase, what will happen means this will undergo and hit on the bonded electrons. Bonded is silicon atom 4 electrons. This minority carriers and majority carriers when I am giving doping. So other than doping, there are some stable atoms are there, stable electrons are there. So because of the movement of the minority carriers, these minority carriers go and hit on stable electrons. Stable electrons, suppose this is one electron. This is going and hitting on a silicon atom, a stable silicon atom. So that stable is hitting, it will eject one electron. It will take out one electron. So now there are two free electrons. These two free electrons are there. These two free electrons are moving in next two direction, and this will hit another free electron, and this will hit another electrons are pluck out, take out. So totally four. How many electrons are there now free? 4 electrons Okay, here we have one electron. Every electron, it is moving very fast and hitting on another silicon atom. So from there one electron will come. So now how many? Two free electrons. Two will be there, previous one and current new one. These two again traveling with very high, I am giving very high voltage. Then these two are moving, these two are hitting on two another silicon atoms. So each silicon where electron it will hit, this will hit on another silicon. So 2 become now how many number? 4 numbers. This 4 will go and hit, so this will create how many numbers again? 8 will go and hit next 8, so it become 16. So this is kind of a chain reaction. 2 become 4, 4 become 8, 8 become 6. Minority carriers are hitting on a silicon atom and the number of free electrons are generating cumulatively. Cumulatively means number higher വരുന്ന ആ ഒരു സ്റ്റേജ് ആണ് ഈ സ്റ്റേജ് down. அது ஒரு ஸ்டேஜ் കഴിഞ്ഞா ആ ഡയോഡ് അതിനെ കൺട്രോൾ பண்ண முடியாது, it will dead. அதான் நான் சொல்றது, நீங்க மொபைல் ஃபோன் மாதிரி you are giving with various charges, right? 2 ampere கொடுக்கணும், 2.1 கொடுக்கணும், 4 ampere கொடுக்கணும், it will struggle every time. So ஒரு ஸ்டேஜ் കഴിഞ്ഞா ஸ்டாப் ன்னு சொல்லுங்க. அதே மாதிரி தான் இது ஸ்டேஜ் കഴിഞ്ഞா this will get ruptured, this will get destroyed. അപ്പോൾ ഈ ഒരു നമ്പർ കൂടി അതിൽ 10 power 6 ഓ 10 power 9 ഓ அந்த ഒരു റേഞ്ചിൽ എത്തുമ്പോൾ what will happen? This will be get completely destroyed. Diode will completely destroyed means large number of which current will be here? Minority current will be shooted up. That breakdown is called avalanche breakdown. In case of avalanche breakdown, the concentration means concentration of P and concentration of N is moderate ആയിരിക്കും. Highest doping ആവില്ല, ഒരു average doping ൽ വെക്കുന്ന ഡയോഡ് ആയിരിക്കും. ആ ഡയോഡിൽ നോർമലി നടക്കുന്ന ബ്രേക്ക്ഡൗണിനെ சொல்ற പേരാണ് avalanche breakdown. That is due to the multiplication of what? Minority carriers in simple way, in simple terms. Understood? So avalanche breakdown. Avalanche breakdown is due to multiplication of minority carriers. Multiplication of minority carriers. Due to the reverse bias voltage, a free minority electron can move with high energy and hit on a stable silicon atom and from there next minority electrons are created. From there next minority electrons are created. Now there are totally 2 minority electrons. Now there are 2 minority electrons. This will undergo again collision with another 2 silicon atoms and produces totally 4 free electrons. Next point, this is a cumulative process. Means can add cumulative meaning. This is a cumulative process and leads to the generation of this is a cumulative process and leads to the generation of and leads to the generation of large number of free carriers. Next one, Zener breakdown. Zener breakdown. Zener breakdown. Zener breakdown. Zener breakdowns. Okay. This is only happening in Zener diode. Right. This is only happening in Zener diode. This is only happening in Zener diode. This is only happening in Zener diode. Zener diode, you know, we are going to learn that it's a special kind of a diode. Okay. Okay. So in this diode, the doping concentration of P and N. The doping concentration of P and N regions are very high. Doping concentration higher. Doping concentration of P and N regions are very high. Okay. If P and N doping, it's very high. So what will happen? There should be a depletion region. A depletion regions voltage, barrier potential adhigama irukum. Barrier potential adhigama irukumbodhu what will happen, sir? No current. Barrier potential adhigama irukkumbodhu doping increase cheyyumbodhu, when doping increases, the width of the depletion region is smaller, decrease ചെയ്യും. ഡോപ്പിംഗ് ഇൻക്രീസ് ചെയ്യുമ്പോൾ വിഡ്ത്ത് ഓഫ് ഡെപ്ലീഷൻ റീജിയൻ. അപ്പോൾ വിഡ്ത്ത് ഡിക്രീസ് ചെയ്യുമ്പോൾ ഇലക്ട്രിക് ഫീൽഡിൻ്റെ ഇക്വേഷൻ എന്നാ? ഇലക്ട്രിക് ഫീൽഡ് E ഈസ് ഈക്വൽ ടു വാട്ട് വി ഹാവ് ലേൺഡ്? E ഈസ് ഈക്വൽ ടു V ബൈ L. കറക്റ്റാ? അപ്പോൾ വോൾട്ടേജ് ഇൻക്രീസ് ചെയ്യുന്നുണ്ട്. വോൾട്ടേജ് എന്ന് പറഞ്ഞാൽ ബാരിയർ വോൾട്ടേജ് ആണ്. ആ ബാരിയർ വോൾട്ടേജ് അങ്ങ് ഇരിക്കും. ഇപ്പോൾ 0.5 0.7. ബട്ട് ലെങ്ത് എന്ന് ചൊല്ലുമ്പോൾ ഡെപ്ലീഷൻ റീജിയൻ്റെ വിഡ്ത്ത് ഹയസ്റ്റ് ഡോപ്പിംഗ് കൊടുക്കുമ്പോൾ വിഡ്ത്ത് റെഡ്യൂസ് ചെയ്യും. വിഡ്ത്ത് റെഡ്യൂസ് ചെയ്യുന്ന സമയത്ത് ഇലക്ട്രിക് ഫീൽഡ് വിൽ ഹാവ് വാട്ട് happen? Electric field will be increases. ഈ high electric field കാരണം ആ bonds എല്ലാം break ചെയ്യും. അതാണ് Zener diode happen ചെയ്യുന്നത്. Okay, so what we have written? Doping concentration of P n very high. So then the width of the depletion region is very low. Width of the depletion region is very low. Okay, this is an important point. Doping adhigama irukkumbodhu depletion region width kammiyayi varum. Very important, it will ask for exam. Okay, when depletion region width lesser aanu, doping adhigama irukkum, highest doping appo bhayangara carrier crunch out feel cheyum. So adu depletion region width smaller irukkum. When depletion region width decreases, right, when depletion region width increases, when depletion region width increases, as per the equation, E is equal to VB, barrier potential by length. E is equal to VB by L. L decreases, E increases. Electric field increase. So next point, due to the high electric field at the junction, breakdown of the lattice structure happens. If that is happening, what will happen? Large current will starts to flow. Happens, full stop, then right? Large current starts to flow. But normal diode il ponathu which breakdown aanu? Avalanche breakdown. Zener diode il mattumana Zener breakdown ponathu കാരണം അത് highest ആയിട്ടുള്ള ഇതിലായിരിക്കും. Okay, next ഒരു graph plot ചെയ്യാം. This is reverse current versus forward voltage, applied voltages. So ഇങ്ങനെ വരും. നെക്സ്റ്റ് ഗ്രാഫ് ഇങ്ങനെ വരും. ഇതിൽ ഈ ലേറ്റർ വരുന്ന ഈ ഒരു കണക്ടർ ഇതാണ് അവലാഞ്ച് ബ്രേക്ക് ഡൗൺ. Avalanche breakdown. The minimum one. This is called Zener breakdown. This is called Zener breakdown. ഈ ഒരു ലൈൻ ഭയങ്കര തിന്നർ ആയിരിക്കും, ഇങ്ങനെ സീറോ ലൈനോട് ഇങ്ങനെ ക്രോസ്. Zener breakdown, avalanche breakdown. Next point, breakdown voltage of avalanche diode. Voltage of avalanche diode and Zener diode. അതല്ലേ ഗ്രാഫ് എന്ന് കാണുന്നു. Breakdown voltage of avalanche diode. ഇതാണ് avalanche diode breakdown happening in this voltage. ഇതാണ് Zener. അപ്പോൾ Zener-ക്ക് അപ്പുറം avalanche. So avalanche diode breakdown voltages is higher than Zener diode breakdown voltage. Breakdown voltage of avalanche diode greater than Zener diode. Okay. As per the graph. How the graph came, I have to explain. That I'll explain when I go to Zener diode. അതിൻ്റെ മെയിൻ റീസൺ എന്താണെന്ന് കേട്ടിനാ ഇൻ ഷോർട്ട്. ഇപ്പോൾ Zener diode how the breakdowns are happening because of electric field. Okay, because of the electric field only the breakdowns are happening. So അങ്ങ് കൊടുക്കുന്ന ഇലക്ട്രിക് ഫീൽഡാണ് ഈ ബോണ്ടിനെല്ലാം ബ്രേക്ക് ചെയ്യണത്. ഇപ്പോൾ ഒരേ ടൈമിൽ ഒരു അവലാഞ്ചെ ഡയോഡ് എടുത്തു, നോർമൽ ഡയോഡ്, ഒരു Zener ഡയോഡ് എടുത്തു. രണ്ടുക്കും ഒരു എക്സ്പെരിമെൻറ്റ് വഴി യു ആർ ഗിവിങ് 10 വോൾട്ട് 10 വോൾട്ട് റിവേഴ്സ് വോൾട്ടേജ്. Then you are increasing 11, 12, 13, 14, 15. Then you connected with an ammeter to measure the current. You can see the breakdown is happening in Zener diode very fast. Why? Because means ഈ ഇലക്ട്രിക് ഫീൽഡാണ് അവിടെ ബ്രേക്ക് ഡൗൺ ക്രിയേറ്റ് ചെയ്യണത്. മറ്റപടി സൈഡിൽ ഹൂ ഈസ് ക്രിയേറ്റിംഗ് ദ ബ്രേക്ക് ഡൗൺ? ദ കാരിയർ കൊളീഷൻ ആണ്. അപ്പോൾ ബ്രേക്ക് ഡൗൺ ബിൽഡപ്പ് ആവണത്, ഈ ഒരു ബ്രേക്ക് ഡൗൺ ഹാപ്പൻ പണതൊക്കെ ഇലക്ട്രിക് ഫീൽഡ് ബിൽഡ് ചെയ്യണം. ഇലക്ട്രിക് ഫീൽഡ് ഹയസ്റ്റ് വാല്യൂ ആയിട്ട് ബിൽഡ് ചെയ്യണം. അതൊക്കെ വാട്ട് വിൽ ഹാപ്പൻ? ഡെപ്ലീഷൻ റീജിയൻ ഇങ്ങനെ ശൃംഗായി വരണം. ഡെപ്ലീഷൻ റീജിയൻ്റെ വിടുത്ത് കമ്മിയാകുമ്പോൾ ഇലക്ട്രിക് ഫീൽഡ് ഹയർ ആയിരിക്കും. അവലാഞ്ചെ ഡയോഡിൽ ഹൗ ദ ബ്രേക്ക് ഡൗൺസ് ആർ ഹാപ്പനിങ്? കാരിയേഴ്സ്, ഒരു കാരിയർ, സെക്കൻഡ് 4, 8, 16, 16, 32. ആ പ്രോസസ്ക്ക് ടൈം എടുക്കും. ഇലക്ട്രിക് ഫീൽഡ് ഹയർ ആവതൊക്കെ ഡെപ്ലീഷൻ റീജിയൻ്റെ വിടുത്ത് ഇങ്ങനെ കമ്മിയാണ്. കാരണം സ്റ്റാൻഡേർഡ് ഡെപ്ലീഷൻ റീജിയൻ്റെ വിടുത്ത് 10⁻⁻6 മൈക്രോമീറ്റർ ആണ്. അപ്പോൾ അത് ഒരു യൂണിറ്റ് കമ്മിയായിനാൽ മൈക്രോമീറ്റർ റേഞ്ചിലാണ് അത് കമ്മിയാവുന്നത്. ഇപ്പോൾ 10⁻⁻6 എന്ന് വീണ്ടും കമ്മിയായാൽ 10⁻⁻7. അപ്പോൾ അതിൻ്റെ എഫക്റ്റ് ഭയങ്കര ഹൈ ആയിരിക്കും. അപ്പോൾ ആ ഇലക്ട്രിക് ഫീൽഡ് ജനറേറ്റ് ചെയ്യുന്നത് ഭയങ്കര ഹൈ ആയിരിക്കും. കമ്പയറബിൾ ടു 2 become 4, 4 become 6, 6 become 12. അതേമാതിരി പോണ പ്രോസസ്സിന് കമ്പയറബിൾ ടൈം ടേക്കൺ ഹിയർ ഭയങ്കര സ്ലോ ആയിരിക്കും. അതുകൊണ്ടാണ് Zener ഡയോഡിൽ ബ്രേക്ക് ഡൗൺ ഭയങ്കര ഫാസ്റ്റ് ആയിരിക്കും. അവലാഞ്ചെ ഡയോഡിൽ കൊഞ്ചം ടൈം എടുത്തിട്ട് മെതുവാണ്. അണ്ടർസ്റ്റുഡാ? Okay, then we'll go to do one question. So write down. Find the current flowing through the diode. So far everybody understood? Yeah? So very understood? Okay. Find the current flowing through the diode. Diodes are ideal. Find the current flowing through the diode. D1 is that D1. Diodes are ideal. diodes are ideal. ഈ ക്വസ്റ്റ്യൻസിൽ ഡയോഡ്സ് ആർ ഐഡിയൽ കേട്ടിന ഡയോഡുക്കുള്ള ഡ്രോപ്പ് ആവണ നീ വോൾട്ടേജ് യു ഡോണ്ട് വാണ്ട് ടു കൺസിഡർ. യു ഡോണ്ട് വാണ്ട് ടു കൺസിഡർ എനിത്തിങ് അബൌട്ട് ഡയോഡ്. ഓക്കെ, യു ഫോർഗെറ്റ് ഇറ്റ് ഈസ് ജസ്റ്റ് എ വയർ, ദാറ്റ്സ് ഓൾ. അതാണ് ഐഡിയൽ എന്ന് ചൊല്ലുമ്പോൾ അതിൻ്റെ കണ്ടീഷൻ അതാണ്. ക്വസ്റ്റ്യനിൽ ഐഡിയൽ എന്ന് ചൊല്ലവേ ഇല്ല എന്നാ ജനറൽ ആയിട്ട്. ഇപ്പോൾ ലാസ്റ്റ് 2019 ഇല്ല 19 ഞാനൊരു ക്വസ്റ്റ്യൻ കേട്ടു. കറണ്ട് ഇലക്ട്രിസിറ്റിന് ഒരു വോൾട്ടിമീറ്റർ അമ്മീറ്റർ എല്ലാം ബേസ് ആയിട്ട് വരുന്ന ക്വസ്റ്റ്യൻ. ദേ ടോൾഡ് ജസ്റ്റ് വോൾട്ടിമീറ്റർ, ജസ്റ്റ് അമ്മീറ്റർ. സോ വി ഹാവ് ടു കൺസിഡർ ലൈക്ക് എൻ ഐഡിയൽ അമ്മീറ്റർ, ഐഡിയൽ വോൾട്ടിമീറ്റർ. നോൺ ഐഡിയൽ ആയിരുന്നാൽ സെപ്പറേറ്റ് ചൊല്ലും. Okay, just voltmeter ammeter and just a diode and consider as an ideal diode. Okay, now we'll solve. What we need to find out? Current flowing through the D1 diode. How to find out? 20 volt I am giving. Correct. Positive is connected with the negative terminal of the battery. Sorry, diode. Negative is connected with the positive terminal of the diode. So this diode forward bias or reverse bias? Reverse bias. In the reverse bias, there is a minority current that is zero, that is negligible. Ideal case, resistance of the diode is what? Reverse bias resistance is what? Infinite. Means very high resistance. What you can assume? This diode is not here. This is just disconnected. Okay, when come here, this diode is what connection? Positive is connected with positive terminal of the battery. This is what connection? Forward bias. Forward bias means what is the forward bias resistance? Zero. So zero means this is short circuited. Now the circuit is look like this one. Now the current is flowing through the circuit I is coming here. I is split as I1, I is split as I2. I will not split it as I3 because there is no current flow. It is break. It's broken down. Okay, so what we need to be find out? Current. Which current? I1 current I need to find out. So before that, first I will find I. Okay, so I is equal to voltage divided by resistance. Voltage is 20 volt. Resistance is what? These two resistance. This has no impact. These two resistance is what connection? Parallel connection. So how to find out the effective resistance of parallel connection? R1 R2 divided by R1 plus R2. So I'll put it as R1 R2 divided by R1 plus R2. That is the effective resistance. So will be here 20 divided by 4 into 2 divided by 8. So 20 into 8 6. 4 into, so 20 into 6 divided by 8. Let me put it as 4 into 2. So this can easily cancel. It become 5. This can cancel 3. 5 into 3, 15. 15 is the total current. Correct? So 15 ampere current is flowing through will be here. So how to find out the current flowing through I1? How to find out I1? I into R2 by R1 plus R2. This rule is called? Very good. 15 divided by R2. R2 means what? Opposite resistance. Opposite resistance divided by sum of the resistance. Sum of the resistance means how much? 6. So 15 by, so 15 into 2 by 3. So 30 divided by 3. Answer is 10 ampere. That's all. Okay. Write it step by step. Now you will understand everything. Sometime. Got it up now. But the slum got it. finished first. Okay, if finished, then below, right, assume diodes are ideal, current flowing through the circuit is dash. Assume diodes are ideal. For this question, assume diodes are ideal, current flowing through the circuit is. Assume diodes are ideal, current flowing through the circuit is. Current flowing through the circuit is how much? E by 3R. You can solve, you will solve, I should solve. You should solve. Try. Take time and solve. E by 2R. E by 3R rather than me. Which diode forward bias? E1 forward bias. അപ്പം ഈ ഡയോഡിനെ we can change, right? We can redraw. ഇപ്പോൾ ഇതിൽ ഏത് ഡയോഡ് forward bias? D1 forward bias. അപ്പോൾ അത് ideal diode ആണ് ചൊല്ലുന്നത്. അതിന്റെ മീനിങ് എന്താ? What is the meaning of this one? This can be connected, no resistance means zero resistance, connected by a wire. This is reverse one. So reverse one means what? Infinite resistance, not connected. So ingane varna current, what will happen? Here resistance, here zero resistance. Current will go through resistance or current will not go through zero resistance path. Current will always choose zero resistance path. Here resistance ഉണ്ട്, so current will never go. Current will always choose zero resistance path. So current going up, going come like this. This current will go. So current is equal to what? Voltage by resistance. E divided by 2 resistance are in series connection. E by 2R is the right answer. E by next one. Finished? Got it? Understood? Okay. Next one. Find the current flowing through the circuit. Find the current flowing through the circuit. Assume diode is ideal. Assume diode is ideal. Battery polarity positive negative the 2 volt. Correct side change. If once you change the side, your answer will changes. So 4 ohm, 4 ohm, 4 ohm, 4 ohm. Ellame 4 ohm. You have to find out what is the current flowing through the circuit. give a couple of options. 10 by 3, 10 by 7, 3 by 10, 13 by 10. Current கண்டுபிடிக்கணும். Try, yeah? You will try for next. Got it? எவ்வளோ? 3 by 10. Okay. First diode forward bias, reverse bias. But current is not flowing. Resistance is infinity. Apanga cut and open out. Okay, there are no connection. So how the circuit will look like? Circuit will look like this one. There is nothing. Okay, so current cannot flow here. Current will not flow here. So this branch is not there. Okay. Okay, so now in this case what happens? The current will come here, correct? Current will come here, current is splitted here. Suppose this is I current, so this is I1, this is I2. Okay, when the I2 comes here, for example, I2 cannot go here, I2 can go like this only. So this I2 will come here. So this I2 coming here, I1 is coming from here. So this is again I1 plus I2. This is going like this. So this is happening. So what are all the resistance are in series connection? In series connection, current is same. So see, I2 is flowing like this. So these two are series. Now I am redrawing the circuit. So I have a 4 ohm. These two, listen to the board, these and the same I2 is flowing. So these connected as a parallel circuit 4. From there I have another one. What is that another one? 4. Now this all together is connected with a voltage. What is that voltage? 2 volt. Which one? 4, 8. Okay. Lower one is 8. Series connections 8. Okay. Correct. These two are parallel. 4 plus 4, 8. Now this 8, these two together 4, 8. This 8 is in parallel with 4. So 8 is in parallel with 4 means total resistance is how much will come? 8 into 4 divided by 8 plus 4. Then we have another 4. This is connected with what voltage? 2 voltage. So 8 into 4, 32 divided by 12, 16 by 6, 8 by 3. Okay, so current equal to voltage by resistance. Voltage how much? 2 volt. Resistance 8 by 3 in series with 4. So 8 by 3 plus 4. We have to simplify this. So 3 is taken as LCM. 8 plus 3 into 4, 12. So which is equal to 2 into 3, 6 whole divided by 20. So answer is 3 by 10. 3 by 10. Got it, huh? Reverse ആണത് കട്ട് ആവും. ബാക്കി സീരീസ് പാരലൽ കോമ്പിനേഷൻസ് ആവുക ഒത്തപ്പെട്ടൊന്നുമില്ല. ഇത് ഒരേ കറണ്ട് പോകുമ്പോൾ സീരീസ് അതാണ് ഇതിൻ്റെ. കാരണം ഈ I1 ഇങ്ങനെ പാസ് ആവാൻ മുടിയാതെ. Because if I1 is passing means I1 will rotate. അതുകൊണ്ടാണ് I2 will passing like this one. Correct? So I2 will go upside and this I2 along with I1 will join and the circuit will flow like this. Finished up? Write the next question. We should be thorough, then only we can able to. Current flowing through the resistor R3. Find the current flowing through the resistance R3. We'll see. Find the current flows through the resistance R3. In the level kita kek itu kumelan kekar. Zero 0.3 5. Okay. We'll see. No. 2 ampere, huh? Okay. I didn't remember the answer, only I wrote down in my notebook, only the question. And I have done neatly some homework, neatly some homework. Okay. 50 ohm, 50 ohm, 50 ohm, 100 volt, D1, D2, D3, D4, 4 diodes. Okay. Which diodes are forward biased? 1, 2, 4. 3 is reverse bias. So which one will cut? Second branch will cut off. Correct? So no current here. Every branch wire cut, there is no current at all. So you can completely forget about it. Okay, completely forget about it. Next, what will happen? This is an ideal diode. Ideal diode means what? 0. So forward bias are the connect here. This is forward bias. So this is connect here. Total resistance we can find out. What is the total resistance? Effective resistance is what? Two resistance are in parallel. So R1 R2 divided by R1 plus R2. 50 into 50. 2500 divided by 100. So it become 25 ohm is the total resistance. Next, current is equal to voltage by effective resistance. Voltage is 100. Resistance is 25. So how much ampere current will flow? 4 ampere. So now 4 ampere is flowing through this one. Okay. So this is given us like I2, okay, I3 and I1, like this one. I3 and I1. So what I need to be find out? I3. I3 is equal to total current into I into R1 divided by R1 plus R3. Current division rule. Current is equal to how much? 4. R1 means 50. Total resistance 100. So cancel. This become 2. 4 by 2. 2 ampere. Okay, understood? Next question. Given diodes are not ideal, the given diodes are not ideal, value of, find the value of I1 and I2. Find the value of I1 and I2. Okay. Previously, I have written the knee voltage of silicon diode is how much? 0.7. For germanium, we have written 0.3 or 0.5. So can you correct that? Knee voltage of silicon is 0.7. Knee voltage of germanium is 0.5. Gallium arsenide ആണ് 0.3 വരുന്നത്, but it's not there in the syllabus. It's not required. So silicon 0.7, germanium is 0.5. Okay, please correct it. Okay, then draw the next question. Assume the diodes are non-ideal. Find the values of I1 and I2. That is a question. Of 45 minutes backup இருக்கும் சந்தியா, அதுக்கப்புறம் தான் ஆகும். ஓகே, so what we need to be find out I1 in the value, I2 in the value. I1, I2 value has to find out. I1, I2 value has to find out. Correct answer சொல்லுங்க சஸ்டம்.
0.03 I1
okay.
I1 0.02.
Okay, 0.025, 0.25.
0.03 I1. 0.25 I1.
Okay. Emma. Okay. I1 value, I2 value. One is a silicon diode, another one is a germanium diode. One is a silicon diode, another one is a germanium diode. Okay, so 10 ohm, 20 ohm, I1, I2, 1 volt, and yeah. So how to find out which diode is forward bias? Which diode is reverse bias? None of them. So both germanium and silicons are forward biased. This is what type of diode? Ideal diode or non-ideal? Non-ideal. Non-ideal means it should take some voltage. This will take how much? 0.7 voltage. This will take 0.5. So what is the total voltage available on the upper branch? 1 volt ആണ്. ആ 1 volt ഇവിടെ full available ആയിരിക്കും ഈ ബ്രാഞ്ചിൽ. അതേ 1 volt ഈ upper branchിൽ available ആയിരിക്കും. But ആ 1 volt ന്ന് ഈ ഡയോഡ് എவ்வளவு എടുക്കും? 0.7 will take. So what is the balance? 0.3. So I1 equal to 1 minus 0.7. I can write like this one, right? Divided by 10. So 0.3 divided by 10, 0.03 ampere. Correct. I2 is how much? Total 1 ആണ് ആ 1 ന്ന് 0.5 എടുക്കും. So 1 minus 0.5 divided by 20, 0.5 divided by 20, 0.025. Kata? 0.025. Okay, so write the first point. Zener diode is a specially designed diode. Zener diode is a specially designed diode which is having high doping concentration. 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 The diode is called Zener diode. Okay, normal diode മാതിരി தான், ബട്ട് ഇതിൻ്റെ ഒരു സ്പെഷ്യാലിറ്റി, രണ്ട് സ്പെഷ്യാലിറ്റി. ഒരു സ്പെഷ്യാലിറ്റി ഡോപ്പിംഗ് കോൺസെൻട്രേഷൻ ഹയർ ആയിരിക്കും. ദെൻ നോർമൽ ഡയോഡ് നടക്കുന്ന അവലാഞ്ചെ ബ്രേക്ക് ഡൗൺ, ഇങ്ങനെ പോണത് സീനിയർ ബ്രേക്ക് ഡൗൺ. അതാണ് നോർമൽ ഡയോഡ് എന്ന് സീനിയർ ഡയോഡിനുള്ള സ്പെഷ്യാലിറ്റി. അപ്പോൾ അത് നോർമൽ ഡയോഡ് മാതിരിയല്ല, സംതിങ് ഡിഫറെൻറ്റ്. മീൻസ് ഡോപ്പിംഗ് കോൺസെൻട്രേഷൻ ഹയർ ആക്കും. ബ്രേക്ക് ഡൗൺ നടക്കുന്നത് ഒരു സ്പെഷ്യൽ ബ്രേക്ക് ഡൗൺ ആണ്, ദാറ്റ് ഈസ് കോൾഡ് സീനിയർ ബ്രേക്ക് ഡൗൺ. ഓക്കെ, അതാണ് ഇത്. ഇറ്റ്സ് എ സ്പെഷ്യലി ഡിസൈൻ ഡയോഡ്. ഓൺലി ഡിഫറൻസ് ഈസ് ഡോപ്പിംഗ് ഈസ് ഹൈ. അതാണ് ഫിസിക്കലായിട്ട് നമ്മൾ എക്സ്ട്രാ പണണത്, വേറെ എല്ലാമേ സേഫ് தான். ഓക്കെ, ഇനി ഈ സെനർ ഡയോഡിന്റെ സിമ്പിൾ എന്നാ? സിമ്പിൾ എന്നാ? സെയിം ഡയോഡ് ബട്ട് സ്ലൈറ്റ്ലി ഡിഫറൻസ്, റൈറ്റ്? യു നോ. ഓക്കെ, ആരോ ഇങ്ങനെ ഒരു കട്ട് എടുക്കും. ഓക്കെ, സോ ദിസ് ഇസ് കോൾഡ് Zener diode. Zener diode പോസിറ്റീവ് ഏത് സൈഡ്? സെയിം സൈഡ്. ഈ സൈഡാണ് പോസിറ്റീവ്, ഈ സൈഡ് നെഗറ്റീവ്. So Zener diode positive symbol of the diode. Okay, Zener diode use ചെയ്യുന്നത് എങ്ങനെ? Zener diode ന്റെ main use, there are a lot of use cases are there for Zener diode. The main use of Zener diode is used as voltage regulator. So write down the heading. Zener diode main application. Zener diode main application as regulator. Regulator means what? To control something. Fan regulators in there. What it will do? It is used to control the speed of fan. So everything will have a regulator. If a microwave oven എടുത്താൽ അതിനുണ്ട് ഒരു regulator, അതിന്റെ temperature control ചെയ്തിട്ട്. കേട്ടോ, ഫ്രിഡ്ജ് എടുത്താൽ ഫ്രിഡ്ജിക്കുള്ള ഒരു റെഗുലേറ്റർ ഇருக்கு, അതിന്റെ ടെമ്പറേച്ചർ, അതിന്റെ കൂളിംഗ് എഫക്റ്റ് കൺട്രോൾ പണ്ണത്. സോ എവരിതിങ് വിൽ ഹാവ് എ റെഗുലേറ്റർ. റെഗുലേറ്റർ മീൻസ് ഐ നീഡ് ടു കൺട്രോൾ സർട്ടൻ കണ്ടീഷൻസ്. അത് ടെമ്പറേച്ചർ ആവാം, കൂളിംഗ് എഫക്റ്റ് ആവാം, ഏതോ എടുക്കാം. സോ Zener diode യൂസ് ചെയ്യുന്നത് വോൾട്ടേജ് റെഗുലേറ്റേഴ്സ് ആയിട്ടാണ്. വാട്ട് ഈസ് കോൾഡ് ഈസ് യൂസ്ഡ് ആസ് എ റെഗുലേറ്റർ. സ്പെസിഫിക്കലി ഇറ്റ് ഈസ് കോൾഡ് വോൾട്ടേജ് റെഗുലേറ്റർ ഓർ ഇറ്റ് ഈസ് ആൾസോ കോൾഡ് വോൾട്ടേജ് സ്റ്റെബിലൈസർ. ഇതൊക്കെ വോൾട്ടേജ് റെഗുലേറ്റർ ആയിട്ട് യൂസ് பண்ணണം. അതിന്റെ യൂസ് என்ன? വോൾട്ടേജ് റെഗുലേഷൻ ഇല്ലാന്നാ എന്നാ പ്രശ്നം? ഇപ്പോൾ ഫ്യൂസ് വയർ ഇരിക്കെ, എവരിബഡി ഓൾ അവർ ഹോം വിൽ ഹാവ് ഇറ്റ്സ് കണക്റ്റഡ് വിത്ത് ഫ്യൂസ്. കറക്റ്റാ, എക്സ്റ്റേണൽ ആയിട്ട് ഒരു ബോർഡ് இருக்கும், அந்த போர்டுக்குள்ள ஃபியூசஸ் இருக்கும். அதுக்கு MCB എന്ന് പറയും, മിനിയേച്ചർ സർക്യൂട്ട് ബ്രേക്കർ. കേട്ടിരിക്കீங்களா? MCB ബോർഡ് അത് ഒരു ഫ്യൂസ് ആണ്. ആ ഫ്യൂസിന്റെ മെയിൻ പർപ്പസ് എന്ന് കേട്ടിനാ ഈ കറണ്ട് AC ഇതെല്ലാം വർക്ക് ചെയ്തിട്ട് ഹൗ മച്ച് ഇസ് എ വോൾട്ടേജ് റിക്വയർഡ്? 240 വോൾട്ട് ആണ് അതിന്റെ വോൾട്ടേജ്. ആ വോൾട്ടേജ് അധികം വന്നാൽ വാട്ട് വിൽ ഹാപ്പൻ? ദിസ് വിൽ ഗെറ്റ് ഡാമേജ്ഡ്. അപ്പോൾ അതിനെ പ്രിവെന്റ് ചെയ്തിട്ട് പിന്നെ ഫ്യൂസ് വെക്കണം. അപ്പോൾ ഫ്യൂസൊക്കെ ഹൈ വോൾട്ടേജ് ആണ്, ഫ്യൂസിന്റെ വയർ കട്ടാവും. Okay, that is a thing which is happening in fuse. Appa fuse is act as a regulator to prevent or it is saving my electronic devices. Okay, so that is the purpose of fuse. Similarly, if normal all of your home will have refrigerator, right? Refrigerator in the male mostly your tappa will be there. Regulator, we got it. Stabilizer. Correct. Okay, there is a stabilizer will be there. Why there is a stabilizer is required only for fridge? Why you are not using it for fan? You not using it for AC? Why you are only using it for stabilizers? Only for fridge. Correct. TV ke stabilizer irukingala? Irukkum. Maybe some homes TV will have stabilizer. Then fridge ke stabilizer. Washing machine will have stabilizer? No chance at all. Correct? No stabilizer. Why not using stabilizer for washing machine? Do you think about that? TV stabilizer. Fridge is common. Okay, 99% Indian homes will have refrigerator stabilizer for refrigerator. Similarly for TV. Why we are not giving machine? So what is the reason, sir? Why we are not giving for washing machine? Washing machine, fridge, TV, there devices, bulb there is no stabilizer. Why? The one reason is initially when stabilizers are found out, stabilizers are mainly used for high cost devices. For example, your room will cost an AC. AC can stabilizer use. AC use. We started to use for fridge, refrigerator. That's useful. Correct. That is required stabilizer. TV stabilizer required. Washing machine stabilizer is required, but we are not using. That's the reason that's a tradition. Okay. AC stabilizer, TV washing machine stabilizer. Washing machine stabilizer, washing machine high voltage. But as a tradition, we are continuing our box. TV must stabilizer. Okay, that's the refrigerator. But washing machine stabilizer, high voltage TV. Damage, same situations, the washing machine also get damaged. Okay, everything will need a stabilizer. What is the purpose of stabilizations? Suppose if you are taking a TV, a TV in the box and a man, like a mobile phone, like a charger. If today go to your home and see your mobile charger, there it is written 2.5 volt or approximately equal to, like a dotted line to 5 volt. Okay, 2.5 to 5 volt means 2.5 to 5 volt mobile device in the voltage mobile is safe. Mobile is able to work very perfectly. 2.5 volt to 5 volt. Suppose you are giving 20 volt into mobile, what will happen? This charger will reduce it to 5 volt. And step up transformer, step down. This will step down and make it 5 volt and give to the mobile phone. And if you are giving 1 volt, what will happen? It will step up. Regulator purpose what is required for the device to work. My mobile phone required 5 volt. If you give 1 volt, I will give 5 volt. If you give 100 volt, I will give 5 volt. But 1 volt is danger. Because 5 volt is a device work. 5 volt device work. 1 volt I can say I will not work. Because I need how much voltage? 5 volt. You are giving 1 voltage, I will not work. No problem. The device is not complained. But if you are giving 100 volt, definitely I have to act very quickly. I have to reduce to 5 volt, then I have to give. I cannot say like that. I don't have any time. It's just like 1 second, everything will go off. Okay. High voltage varanadana risk. One device low voltage varanadu risk alla. Kana low voltage device cut out. Means just to off out. It will not work. Sometimes in your home, at least in this last 10 years, you may observe like that. Whenever voltage is very low, sometimes motor will not work. AC will not work. AC will cut. Okay. Why? Because voltage is very low. Fridge or TV, something which will not work at all. But no problem, next time when a good voltage will come, it will work as usual. But some very high voltage will come, your TV is gone, means tomorrow it will not turn on. Correct? High voltage is a risk, low voltage risk illa. High voltage in the risk avoid to reduce the high voltage risk, we are using what? Zener diode as voltage stabilizer. Voltage is stabilize. Stabilize means what? Constant voltage. Okay, constant voltage high voltage cut constant voltage will be given to the device. Our device is save. But a stabilizer there will not be any complaint. You know how much is the cost of building a stabilizer? With stabilizer what are all the things are required? What are the things are required? Two resistor or diode. That is the only things which is required. What is the cost of a Zener diode? 70 paise. 70 paise, less than 1 rupee. Okay, what is the cost of a resistor? 1.5 rupee. Okay, so total circuit within 5 rupees we can make a beautiful diode, but a box evlo kodutittu vaangittirukku. Okay, it's very weight, right? Adu edukku very weight because adukulla oru step down transformer undu. A step down transformer coil magnet adana adinte weight eppozhum adoru high weight irukkum. Appo adana circuit bayangara idha. So total cost of manufacturing is less than 100 rupees, but you are giving greater than 500 rupees we are buying, right? Adana business. Okay. So welcome. Write the Zener diode main application as regulator. Zener diode used as voltage stabilizer. Zener diode used as voltage stabilizer. Voltage stabilizer. Used as voltage stabilizer. Okay, next don't write anything. We will write first. We'll learn how it is working as a regulator, then we'll learn. Okay, voltage stabilizer. Voltage stabilizer. ഇതാണ് ഈ സ്റ്റെബിലൈസറിൻ്റെ സർക്യൂട്ട് ഡയഗ്രാം. നൗ വി ആർ അറ്റ് സർക്യൂട്ട്സ്. സോ വോൾട്ടേജിൻ്റെ വി ഇസെറ്റ് ആൻഡ് ആർ ആൻഡ് ദിസ് ഇസ് വി. Okay, what is there? This diode is connected. Listen very carefully. This is positive, negative. Positive is connected with the what terminal? Negative terminal. Negative is connected with the positive terminal. So the diode is what biased? VZ bias, reverse bias condition. So reverse bias diode will have a reverse characteristics. Correct? What is the reverse characteristics of a diode? Current versus voltage graph. Current versus voltage. Zener will have a minority current, then will have a breakdown. This breakdown is called Zener breakdown, or we can say breakdown, simply called Zener breakdown, as it is a Zener diode. So this line is the cut down. Okay, now this voltage, this is what? This is the applied voltage. Okay, this is called what? Reverse current. Current is flowing through the device is called reverse current. Next, this is the voltage which is giving. You can assume this is coming from your outside or outside of your home from the transformer. This is a voltage which is coming. Okay, DC or AC, no problem. Here I just connect as a voltage. The load RL resistance. Load in Sulama, it may be a TV, it may be fridge, or any load, any element which is having a resistance. Anything. Okay, TV എടുത്താലും ഫ്രിഡ്ജ് എടുത്താലും എണ്ണ എടുത്താലും അതിക്ക് റെസിസ്റ്റൻസ് എടുക്കും. ഇതാണ് കൊടുക്കുന്ന വോൾട്ടേജ്. Okay, ഇതാണ് Zener. Okay, what I will do means first I will pick the device. I will pick the device means first I will pick. Suppose I am going to set up for a device. Device means I have a TV. I want to place a stabilizer. How should I design? I will take my TV. So my TV is RL. So RL is nothing but my television. Okay, so I know my televisions required certain voltage to work. I assume it is a small TV, and for example the small TV will be working with a certain voltage. I am measuring as 240 volt. 240 volt is the voltage required for TV. If you are giving below, no problem, I will not work. But if you are giving me high voltage, that is a problem. I may not work thereafter. Okay, so 240 volt above I will not accept. So what should I will do? So then I will choose a Zener diode. Zener diode will say I need 240 volt here. So what is the voltage of Zener diode? Both are parallel circuit. So I will choose a Zener diode, and Zener voltage is equal to how much? 240 volt. So I will go to shop and I will ask, I want one Zener diode. Zener diode, Zener voltage. Zener voltage means breakdown voltage. Breakdown voltage should be equal to 240 volt. If you go to any electronic shop, there are a lot of shops will be there in Ukkada, that area. So if you go there, if you are asking for a Zener diode, immediately the next question, what Zener voltage you want, they will ask. So immediately you have to say your voltage. So I need 240 voltage because I am going to connect across what? Across my TV. 240 volt you connected. This resistance, this you can choose whatever you want. This is just a current limiting resistance. Okay, you can choose any value. Suppose I am using as 10 ohm for example. Okay, any value. This is a TV in the resistance, total resistance. Suppose I am assuming the resistance of the TV is equal to 100 ohm. Anything, you can choose anything. Now we are finding certain situation. Suppose if I am giving here 260 volt. 260 volt means if this voltage is not there, if this diode is not there, this is a danger voltage, correct? Because it is greater than 240 voltage. So what will happen when you are giving 260 voltage? 260 voltage you are giving to the diode. Whenever the voltage you are giving greater than Zener voltage. Zener voltage is how much? 240. You are giving 260. Next, in the plot I told V is the applied voltage. V is the voltage in which you are giving. The Zener diode characteristic is like this, and this value is how much? 240 volt is the breakdown. But you are giving a voltage which is higher than Zener voltage. So suppose this is 100, this is 200, and this is 300. So you are giving how much? 260. Where it will come? After this line or before this one? After this line. So 260 means somewhere here it will come. Okay. So when you are giving 260, before reaching 260 itself, because you are giving 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it is increasing to 260 within very shorter time. Voltage 0 ആണ് എപ്പോഴും ഇൻക്രീസ് ആവുന്നത്. വളരെ ക്വിക്ക് ടൈമിൽ വോൾട്ടേജ് ഇൻക്രീസ് ആയിട്ട് സഡൻ വാല്യൂ അച്ചീവ് ചെയ്യും വിത്തിൻ മൈക്രോ സെക്കൻഡ് ടൈമിൽ. അപ്പോൾ ഈ ഒരു വോൾട്ടേജ് ഇവിടുന്ന് ഇതുവരേക്കും ട്രാവൽ ചെയ്തൊക്കെ ഒരു ടൈം എടുക്കും. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ടക്കൻ ചെല്ലുമ്പോൾ 260 ആകും. ആ 260 ആവണതൊക്കെ മുന്നാടിയെ വാട്ട് വിൽ ഹാപ്പൻ? Zener will break down. Zener break ചെയ്യും. Zener break ചെയ്തിനാ break ചെയ്യുമ്പോൾ what will happen? High current flow. A Zener break ചെയ്തിനാ what will happen means Zener want to protect this one. So here we have high resistance will be there. Now Zener is breakdown. Zener is breakdown means Zener will now act as a pure conductor. Pure conductor. കാരണം ബ്രേക്ക് ഡൗൺ ചെയ്തു. Semiconductor property, all semiconductor properties are lost. Now it become a perfect conductor. Perfect conductor will have how much resistance? 0 resistance. അപ്പോൾ ഇന്ത്യയിൽ വരുന്ന കറണ്ട് ലോഡിൽ പോകാമേ തിരിപ്പി റിട്ടേൺ വന്നിട്ടു. Okay, so what will happen? You given 260, diode told I protected you because I have not given any 260 to you. I have protected you. അപ്പോൾ ഇതിനെ പ്രിവെന്റ് ചെയ്യും കേട്ടിനാ ഇത് കൂടെ മെജോറിറ്റി ഓഫ് ദ കറണ്ട് പോകുന്നത്. കാരണം ദിസ് വിൽ സ്റ്റിൽ ആക്ട് ആസ് എ വയർ വിൽ ഹാവ് സ്മോൾ റെസിസ്റ്റൻസ്. സോ ദിസ് വിൽ ആക്ട് ആസ് വൺ, ബട്ട് ഹിയർ ദർ ഈസ് എ സ്മോൾ കറണ്ട് വിൽ ഫ്ലോ. There is a small current will flows to the load resistance. Small current, majority of the current will flows through the diode because diode is in what conditions now? Breakdown, because you are above the limit. Above the limit, you are above the limit means it's breakdown. So majority of the current, for example 100 ampere is current coming will be here, means 90 ampere will go here and 10 ampere will go here like this. Okay, so higher voltage Zener നേക്കാളും higher voltage കൊടുത്താൽ Zener കട്ട് ആവും. കാരണം Zener കട്ട് ആവുന്നത് ഇപ്പോൾ 240 കഴിഞ്ഞാൽ അതിക്ക് മേലെ എന്നാ കൊടുത്താലും Zener കട്ട് ആവും. So you are giving 260, Zener cut ആയി, major current flows through the Zener diode itself, and this major current will not go to the load resistor. Load ku പോകുന്നത് minimum current ആണ് 10 ampere പോകും, safe ആണ്. Okay, the TV will work. Next conditions. Next condition is what? Next conditions, I am giving the same situations. I am giving the same Zener diode is placed over here, but instead of giving 260, I am giving as 230 voltage. What is the Zener voltage will be here? 240. So now 230 will comes here. 230 coming here, for example. So 230. Zener is breakdown or not breakdown? Zener is not breakdown. So Zener is not breakdown means Zener will act as what? It is still in reverse bias. Reverse bias, what is the current through the Zener? See, at 230 voltage we have a minority current. Minority current micro ampere range, small current ഉണ്ടാവുള്ളൂ. So Zener is almost in what condition? Reverse bias condition. Infinite resistance. Infinite resistance means diode will act as an open circuit. Diode will act as an open circuit. So you are giving 230 volt. Suppose I am assuming the current corresponding to 230 voltage is 20 ampere. So what will happen? The current will come here. Diode is open circuited. It is reverse bias. It is not breakdown. So current will not go here. Current will go like this. So the full current is going to the device because it is acceptable. Why? Because 230 voltages, it is safe for the device. Correct? 240 kuda adhigama varakudadu. 240 kuda kammi. You can give any voltage less than 240. So 230 you can give, 239 you can give, 240 you can give, but 241 not allowed. Okay, so 230 kodidana you are here. So current through the Zener diode is almost zero, no current, which means a diode is in reverse bias. Reverse bias means open circuited, infinite resistance. So current will flows through the RL resistor very safely. Device will work. Whenever a high current is coming because of a thunderstorm in a rainy seasons, thunderstorm വരുമ്പോൾ sudden ആയിട്ട് മേബി ഏതെങ്കിലും രണ്ട് ലൈൻസ് ടച്ച് ചെയ്തതിന് ഹൈ വോൾട്ടേജ് വരും. ആ ഹൈ വോൾട്ടേജ് വന്നിട്ട് സഡൻ ആയിട്ട് ഇതിനോട് 500 ഷൂട്ട് ആയിരിക്കാം. 500 സഡൻ ആയിട്ട് 500. അപ്പോൾ ഈ ഒരു ഡയോഡ് ഉണ്ട്. സ്റ്റിൽ സോ ഫാർ ഇറ്റ് ഈസ് ഗിവിംഗ് വാട്ട് വോൾട്ടേജ്? ഇറ്റ് ഈസ് ആക്ടിങ് ആസ് എ റിവേഴ്സ് ബയസ്. നൗ 500. Zener voltage is how much? 240. So I am here at 500. Zener is breakdown. Zener is wake up. So what will happen? Current, it's not flowing here. Majority of the current is coming here like this, like this, like this. Only small current will go here. Okay, so 500, I am not passing the full current. Suppose if you assume you are giving 500 voltage will be here, there is no Zener diode. 500 corresponding at, maybe I am assuming a current of 150 ampere. 150 coming here, what will happen? Device, okay, it's gone. Okay, so ഈ ഡയോഡിനെ പ്രൊട്ടക്ട് ചെയ്യണം. Diode is used to protect the load resistance. അതിനെ പ്രൊട്ടക്ട് ചെയ്യാനാണ് this we are using it. Understood the concept? Then we will write. First draw the circuit, then we will write. We have to mark the current also. IL, IZ, I, resistance V, and VZ and RL. Below, right? The purpose of Zener diode, is to give a stable output voltage. The purpose of the Zener diode is to give a stable output voltage. Is to give a stable output voltage. The purpose of the Zener diode is to give a stable output voltage to the connected load resistor, RL. To the connected load resistor RL. Okay, case 1 anneda. First case 1. Case 1 is V greater than VZ. V greater than VZ. V greater than VZ. Applied voltage greater than Zener voltages. Okay, applied voltages is greater than Zener voltage. This graph also you can draw somewhere. Of course you know this graph, but V greater than VZ. Okay, draw this graph along with the circuit diagram. I forgot to tell you. I hope you have drawn, or else not drawn. Please draw that graph also. Then just mark here one point, V greater than Vz. V greater than Vz, and this is another point, V less than Vz. Mark these two, V greater than Vz and V less than Vz. And the point before and after the breakdown. Okay. Case 1. When V greater than Vz, point by point, Zener diode is under breakdown. Zener is under breakdown. Zener diode is under breakdown. When V greater than Vz, Zener diode is breakdown. Zener break edu. Zener break edina. What is the now the circuits will look like this one. Please draw the circuit. Resistor, Zener diode is breakdown. Zener diode break edina. Zener kuda current will flow. Correct? So I short circuited. Current flow you because we are here. So Zener is already act as a conductor. So this is short circuited and will be here. Okay, Zener will work. Zener will act as a and the voltage at this point, these 2 points you have to mark it as this. The voltage at this point is Vz. Just give 2 marks. Zener is under breakdown and Vz is equal to, here is the voltage which is called Vz. If this voltage is Vz, what is the voltage here also? Vz. Voltage from here to ground, Vz. So okay, so there are set of current will be there. This is a total current I. This is the Z current. This is the load current. Okay, now we are going to calculate the different current. See, I equal to, can you tell me I means the difference of voltage. What is come? V minus Vz divided by Zener break ചെയ്ത അവിടെ Zener voltage ഉണ്ടാവും. V minus Vz by the resistor called R. V minus Vz by R. Correct? Zener across voltage ഉണ്ടായിരിക്കും. ആ voltage ആണ് Vz. V minus Vz divided by R. What is the load current? ഇങ്ങ ഇരിക്കുന്ന voltage എவ்வளോ? Vz. അതേ voltage ആയിരിക്കും ഇങ്ങ ഇരിക്കുന്നത് because it is parallel connections. Parallel connections voltages are same. Vz here, Vz here. Okay. So IL equal to Vz divided by RL. Vz ആണ് ഇവിടെ ഉണ്ടാകുന്ന voltage. So let me put it like this one time. This voltage is called Vz. അവിടെ ഉണ്ടാകുന്ന voltage ആണ് Vz. Zener short circuit ചെയ്ത് current pass ചെയ്യും. അവിടെ ഉണ്ടാകുന്ന voltage ആണ് Zener voltage. Next one. What is Iz? Iz equal to I minus IL. Correct? Total current minus load current. കാരണം I എന്ന് പറഞ്ഞ current വരും. That is splitted as IL plus IZ. So this is the first equation, second equation and third equations. Okay. So മൂന്ന് current. Zener കൂടെ പോണ current I minus IZ. This is the question is normally asking. Okay. Then next one. Power dissipation. Power at RL. PL. Power at RL. Power at RL, load resistance. ഇതാണ് RL resistance, load resistor. ഇതിലുള്ള power how should I convert? Power equal to voltage to current. Okay, so voltage means VL into IL. What is VL? VL is a voltage here. What is that called? VZ. So VZ into IL. That is power at L. Okay. Ini power at Zener diode is what? Vz into Iz. Power at Zener diode. Okay. And one more thing, power at resistor R is what? Voltage into current. What is the voltage? V minus Vz into total current I. Correct? V minus Vz. ഇതാണ് power at resistance. ഇവിടെ ഉണ്ടാകുന്ന voltage into current. VI. V means here V voltage, here Z voltage. So what is the total voltage across them? V minus Vz. into current flowing through them is I. So 3 current equations, 3 power equations, important. Power dissipation. Okay. Next one, next case 2. Case 2, second case. Case 2. Case 2 is what? V less than Vz. V less than Vz. Zener diode doesn't break. Zener diode doesn't break. It is in reverse bias condition. It is in reverse bias condition. It is in reverse bias condition. This side is already written, right? Yes. It's already in reverse bias condition. So how the circuits will look like? Positive, negative battery, resistance, diode is open circuited. Diode is open. And here we have RL, we have R, we have V. So I is Z, and we have IL. What is IZ? 0. Diode will act as in reverse bias, so it will not be open. IZ equal to 0. What is I? I is equal to IL. Rendu same alla. I is equal to IL. What is the value of this one? Voltage by total resistance. R plus RL. R plus RL. Right? What problem? The value of I is Z. The value of I is Z for the given circuit. For the given circuit is dash. Zero, huh? Okay, next option. Next option. We'll see, huh? Okay, first question, case 1 or case 2? Case 1, Zener is breakdown. Okay, Zener breakdown chedu, Zener breakdown cheyidina Zener voltage 50 is effective. Okay, what we need to be find out? IZ find out is gonna, first I am finding out IL means what? IL is the voltage across here, this voltage by this resistance. What is the voltage here? The same voltage. So it is VZ. If 50 and everything 50. So 50 divided VZ divided by RL. VZ is 50, RL is 10. So it become 5 ampere. Okay, 5 ampere. Next we are going to find out total current I. Total current I means what? I is the current flowing through this one. Appo ee rendu point nadukkulla voltage. Here how much? V voltage. Here how much? VZ voltage. Okay, so V minus VZ whole divided by the resistance 2. V means how much voltage? 100. VZ means how much voltage? 50 divided by the resistance 2. So 50 divided by 2, it become 25 ampere. So 25 ampere is a current coming from here. Okay, so current coming from here is 25 ampere. Then what is the current flowing here? 5 ampere. So what is the balance current here? 25 is coming, 5 is going here, balance is 20. That's all. So I is equal to I minus IL. 25 minus 5, answer equal to 20 ampere. Okay, got it. Okay, so next question. Find the value of power dissipation. Find the value of power dissipation. Find the value of power dissipation across the resistor R. Across the resistor R. Power dissipation across the resistor R. We would like to calculate the power dissipation across the resistor R.
Hmm?
37.5. 12.5. Okay, so we want to find out not the value, like the power dissipation across the resistor R. This power I am giving as P is equal to voltage into current here, V into I. I am keeping like V into I, or I am putting as V dash because V will be here. So V dash into I, or V dash into, okay, V dash into I. V dash is a voltage here. Okay, this is case number 1 or case number 2. Case number 1, Zener is breakdown. So 5 voltage has to consider. So what is the voltage between these 2 points? This is the voltage. So V dash is equal to 10 minus 5. V minus VZ. V minus VZ. 10 minus 5 is equal to 5. That's all. Okay, now I have to find out the current. How should I find out the current? Current equal to V minus VZ again divided by its resistance R. So V minus VZ already I got 5 divided by resistance 2, answer is 2.5 ampere. Power dissipation equal to V dash into I. I already written here. V dash is 5 into 2.5. 12.5 watt. 12.5 watt. Okay. Next question. In the given circuit, what is the value of load current? In the given circuit, what is the value of load current? In the given circuit, what is the value of load current? 10 by 6 വരില്ലേ? First condition or second condition? Case number 2. V is less than VZ. So Zener diode in what condition? Reverse bias condition. When Zener diode in reverse bias condition, it will act as what? It will act as open circuit. Breakdown ആവുമ്പോൾ we have to answer VZ. ഇത് open circuit. So ഇവിടെ കട്ടായി ഒന്നുമില്ല, just കട്ടായി. Okay. Now we have to find out the load current. In this case, V less than VZ. We already know I is equal to IL. Same current അല്ലേ പോണത്. IL, the same current is called IL. So what is I? I and ILs are equal. What is the value of this one? Voltage by resistance. 1 voltage, 2 resistance. So 10 divided by 4 plus 2, 10 by 6, 5 by 3. 1.6 ampere. Next, current through the, for the given circuit, current through the Zener diode is for the given circuit, current through the Zener diode is how much? What's the difference between previous circuit and these circuits? Tell me. What's the difference between the previous circuit? So far we have learned, right? This is not like that one, right? It is same or different? Not different. This is same only. I just drawn in a different way. Okay. This is same than this is same only. See, this 40 ohm resistor. No, this is just to confuse you, nothing else. See, this is same as this one, right? See, this line looking in a straight to it. That's why they fold it. Same line. They will confuse you. This is same. Whatever you have learned, this is same. Now, no difference. What I asked, current through the Zener diode. Same on it. Straight up, you will get confused. But think, okay. Then the same on. 1.2. ABCD சொல்லாத ஒரே ஒரு ஆன்சர் சொல்லுங்க. 1.25. Okay. So 80 volt, case number 1 or case number 2? Case number 1. Zener diode is breakdown. So, this circuit which is the answer here. 10 over 80 over. Okay. So, what is the current flowing here? What is the voltage difference will be here? Here I am writing I. I is equal to, what is the voltage difference between these two points? Here 80. What is the voltage here? 10. What is the voltage here? 80. So 80 minus 10. 80 volt here, 10 volt here. Current is equal to 80 minus 10. Voltage divided by resistance. How much? 40. So it become 7 by 4. 7 by 4. Okay. So what we need to be find out? Zener. So before we are going to find out load current. IL equal to VZ by RL. VZ is how much? 10. RL is how much? 20. 10 by 20. 0.5 ampere or 1 by 2. IZ. எப்படி கண்டுபிடிക്കാം? I minus IL. I is how much? 7 by 4 minus 1 by 2 for LCM. So 7 minus 4 to 2 times. So 2. 7 minus 2. 5 by 4 ampere. 5 by 4 ampere. Okay. Final question. If you are not understanding, please ask immediately. Okay, do not just copy. Okay, current through the Zener diode. Current through the Zener diode is dash. Zero. Which case? Second case. Case number 2. Diode is in reverse biased because V is less than VZ. V less than VZ. Zener diode in reverse bias. In reverse bias. So I is equal to 0 ampere. Answer is 0. That's 2019 Neet question. You remember? No chance, right? Okay. So 0 ampere. Yeah, 2 years back. Next heading, rectifiers. 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 So Zener diode understood, huh? Okay. So rectifiers. What is called a rectifier? Rectifier is a device used to convert AC into DC. Welcome. Little bit of general knowledge. AC into AC is called one AC signal converted into another AC signal. It's called amplifier. Correct? Where? Transformer. Correct? Step up, step down transformer. AC is given, AC you are getting output. So AC to AC converter is called transformer, or as he told, amplifier. Both are correct. Amplifier. AC into DC converter is called rectifier. Then what is else? DC into AC converter is called inverter. Good. Inverter. Then the last one. DC into DC converter is called chopper. Chopper circuits. Okay. AC into AC is called transformer, amplifier. One level AC ne another level AC akku. Step up aim lengi step down cheyum. AC ne DC akuna rectifier. That's what we are going to learn now. Second one, DC ne AC aaki maatanadu, that is called inverter. DC ne DC aaki maatanadu, it's called chopper. One level of DC is converted. For example, something like this one. Suppose I have a 2 volt DC voltage. I want to convert into a 4 volt DC voltage. I will use step up chopper. Similarly, I can convert 2 volt into 1 volt. For that I will use step down chopper. So transformer where format and chopper circuits. Okay, so our context of discussion is what? Rectifiers. Rectifier is a device which is used to convert AC signal into DC signal. Just write one sentence. Rectifier is a device which is used to convert. Rectifier is a device which is used to convert AC signal into rippled DC signal. AC signal into rippled DC signal. Rectifier is a device which is used to convert AC signal into rippled DC signal. AC signal into rippled DC signal. Rippled AC in DC converting. AC signal rippled DC signal converting. Two types of rectifiers we are going to learn. First one, below right, two types of rectifiers. Two types of rectifiers. Two types of rectifiers. What are the two types of rectifiers? Half wave rectifier and full wave rectifier. Okay, so two types of rectifiers. One is half wave rectifier, HWR, and second one is full wave rectifier. Full wave rectifiers are two types. What are the things? Tell me. You told very confidently half wave and full wave. Then two types of full wave. One is called center tapped full wave rectifier. Center tapped full wave rectifier. Another one is called bridge rectifier. Okay. Center tapped, two types of rectifiers, half wave rectifier and full wave rectifier. Next, additional point. Both rectifiers are producing rippled DC signal. Rippled DC signal. Ripple DC signal. What is called rippled DC signal? Rippled DC signal means this is called rippled DC. Rippled DC signal. Both rectifiers are producing rippled DC signal. Okay. To get, next point, to get DC signal from, to get DC signal from rippled DC signal. To get DC signal from rippled DC signal, filter circuits are using. Filter circuits are using rippled DC. The rippled DC signal or filter circuit, we will learn this more in detail. Filter circuit could pass then what we will get? We will get a kind of signal. This is more or less similar to our ideal condition. Ideal DC voltage, how it look like? This is ideal. This is non practical on ideal signal. For rippled DC circuits, we are passing through a filter circuit. Once you passing through the filter circuit, you will get a non-ideal signal, or a non-ideal means original ideal DC signal, more or less similar to practical. Small ripples irukkum, idhe mari periya ripples varadhu. Okay. So we have to learn all these things. We'll go one by one. Full half wave rectifier. First, write the heading called half wave rectifier. Okay, half wave rectifier. Draw the circuit diagram also for half wave rectifier. here this is the primary coil of the transformer and we are giving a input voltage, and this is step down, so secondary coil will have less number of turns. Both should not be equal. This higher number of turns, this lesser number of turns in the secondary coil, and we connected with a diode, then we connected with a load resistor RL. This is a diode D. This is a step down trans voltage. Okay. Next we are going to draw the waveforms also. So V in, which is step down, and you will get V, and this is the voltage, and this voltage available here, this is called V out. This is called V out. Okay, so input voltage is a big sine wave like this, and this is getting stepped down by the transformer. This V in voltage ആണ് കൊടുക്കുന്നത്. In the secondary of the coil of the transformer we are getting V voltage, this one. Diode കൂടെ പാസ് ചെയ്ത് ഔട്ട്പുട്ട് കിടക്കുന്ന വോൾട്ടേജ് ആണ് ഔട്ട്, തേർഡ് ലൈൻ. അപ്പോൾ ഇത് ഹൈ വോൾട്ടേജ്, ഹൈ ആംപ്ലിറ്റ്യൂഡ് ഉള്ള സിഗ്നൽ ആണ്. അതിനെ സ്റ്റെപ്പ് ഡൗൺ பண்ணும். Once it is step down, what you will get? You will get a low amplitude signal, correct അല്ലേ? Yes, you will get a low amplitude signal. You will get a low amplitude signal, which means in the அளவுக்கு amplitude வராது, the amplitude become small and become small like this. So amplitude is small. This is the output of the secondary coil of the transformer, and it is step down. Because high voltage we cannot give to diode in the lifespan overall. Okay, so that's what we are step down into the next level of voltages. Okay. Okay, next what happened? See here we have two cycles will be here, positive cycle, negative cycle, positive, negative, positive, negative, and so on, and it's continuing. Whenever a positive cycle will come, what will happen? For the first positive cycle, what will come? Here it is positive, here it is negative. Positive cycle meaning upper end, first connection positive, then the next connection negative. Appadana our voltage is creating, then only the voltage will be generated, created. So this voltage in my diode forward bias or reverse bias. Positive is connected with the positive, forward bias. So diode got a current pass I into RL, output equal to I into RL. I into RL. I got the voltage. So I got the voltage means I got the same voltage. I got the same voltage. Okay, next negative cycle ആണ് പോണത്. Negative cycle വരുമ്പോൾ മേലെ തന്നെ വരും. So what will be? It will be negative ഇല്ല positive. So negative cycle വരുമ്പോൾ diode reverse bias ആണ്. No current means no voltage. Voltage will be equal to 0. Voltage is equal to 0. Voltage equal to 0. correct? Reverse bias amma current is not flowing through the diode. Current illena voltage is also equal to 0. Voltage also equal to 0. So no current. Again positive is coming. Again positive comes means here positive, here negative. So diode is forward biased, current will flows. Yes, current will flows. So current will flows through the diode. Again negative cycle, no current. Positive cycle, current. Okay, so like this one. This is called half wave rectifier. Why? Because out of the full wave, half of the wave is converted, half of the wave is rectified. Then it is called half wave rectifier. We'll write a note also below. During the positive cycle of the input signal, during the positive cycle of the input signal, during the positive cycle of the input signal, diode D is forward biased, and current passes through the diode, and we will get the output V out, Next one, and we will get the output V out. Next point, during the negative cycle of the input signal, what will happen? Diode D is what bias? Diode D is in reverse bias condition. Hence output equal to 0. Because I equal to 0. Hence output equal to 0. Hence V out equal to 0. Next point, half of the input signal is only converted into output, hence it is called half wave rectifier. Just one additional point, there are many terms are related with half wave rectifier, peak inverse voltage, RMS voltage, but these are not required for NEET. One point is required, efficiency of half wave rectifier, eta equal to 40.6%. This comes through a derivation, so you don't want to learn the derivation. They are not asking this for NEET based, but for JE, these values are required everywhere. Wherever you go, values are required. But efficiency of half wave rectifier is equal to 40.6%. Okay, all understood? Anything? Okay.